Hey guys, Mr. Piercy here, and what we're going to be showing you how to work today is where the formula for distance came from. The distance formula is what we use in geometry to find the distance or the length between 2 points on a coordinate plane. And so what we're going to need for this lesson to kind of follow along is you might need the handout that is attached to this lesson or is attached to this video, Understanding the Distance Formula. You'll need a straight edge of some kind and a pencil, and if you want to, some kind of a calculator just to help you with any arithmetic that we might experience in this lesson. So what this is asking us to do, what this process, this investigation is going to walk us through, is going to show us, well, how was the formula for the distance derived in the first place? Not just, take my word for it, I'm the teacher, but where did it come from? Why does it work? So let's go ahead and take a look at what we have here. There's our graph for the other part. But let's go ahead and walk our way through it and see what we get. So using the coordinate grid, let's plot these points h and k, -4 and -3. So -4, -3. So here is point h. And we have k at 8 and 2. So I'm going to go ahead and take my straight edge and connect the dots. So now we have segment HK, and ultimately what we want to know is how far is it from point H to point K along the graph. Now if it was a horizontal line or a vertical line, we could just count it, but because it's slanted, it has a slope of some kind, we can't just count what we think it is. We have to actually figure it out. So draw a dotted vertical line passing through point K. So through point K, we'll have a dotted vertical line here. Okay, and then the next part says draw a dotted horizontal line through point H, and when we're done we'll see hopefully a right triangle. And that's exactly what we kind of see right here. We do see a little bit of a right triangle. So now let's see, using the coordinate grid, find the shortest distance from point H to the vertical dotted line through point K. And it tells you here this is the length of a horizontal leg. Now remember, a leg of a right triangle is one of the two sides that actually make the right angle of the right triangle. So from point H to the dotted vertical line, just counting, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So I'm going to say that that's 12, and I'll go ahead and put it here. Find the shortest distance from point K to the horizontal dotted line. So from point K, we're going to count down 1, 2, 3, 4, 5 spaces. All right. So record your answer here also. So there's 5. So use the leg lengths from 5 and 6 to find the length of segment HK. Now, how are we going to do that? Well, because it's a right triangle, we can use the Pythagorean Theorem, which says a squared plus b squared is equal to c squared, where a and b are legs of a right triangle, and c is the hypotenuse, which in this case is what segment HK would represent of the right triangle that we see in our graph. So we see one that is 5 spaces long, one that's 12 spaces long. So I get 25 plus 144. And I'm going to just kind of come to the right here, or I'm sorry, the left. So that's going to give me 169 is equal to c squared. So when I take the square root of both sides, I get c equals 13. So we're just using the Pythagorean theorem to show that the hypotenuse of this right triangle is 13 units long. We'll refer back to number 5. Okay, so number 5, we had a length of 12. How could we use the x-coordinates of point H and point K to get the 12 that we found before? Well, the x-coordinates that we have, so I'm going to say the x-coordinate of H, well, that's a negative 4, and the x-coordinate of K, that is a positive 8. Now, looking at these numbers here, we want to say, well, how could we possibly use those two numbers to get a 12? Well, if I add them together, negative 4 plus 8, that's going to give me a 4. So that doesn't work out to give me the 12 that we're looking for. But going back to an earlier concept, the Ruler Postulate, one of the things that says is that the distance between 2 points can never be negative. So if I take the absolute value of those, which is what the Ruler Postulate allows us to do, I can take the difference of those two numbers, and I'm going to get the absolute value of negative 12, and the absolute value of negative 12 must be a positive 12 because, and those are vertical lines, distance can never be negative. So the Ruler Postulate is allowing us to take the difference of the x-coordinates to find the length between the point H and the dotted vertical line. Well, let's look at the y values now. The y value of point H is a negative 3, and the y value of point K is a positive 2. Now we know that the length of the leg of the right triangle is 5 spaces long. And we can see, because one of these is positive and one of these is negative, is that if we add them together, we're not going to get 5. But again, my Ruler Postulate, which says length or the distance of something can't be negative, we can say negative 3 minus 2. I can take the difference of these also, and I'll get the absolute value of negative 5. And the absolute value of negative 5 is the 5 that we counted for the length of that side of the right triangle. So now how can we use that to write a new formula? Well, ultimately what we did is we said the distance between 2 points is really just the hypotenuse, it's really just here, let me erase this and start over. The distance formula is really allowing us to be able to create a right triangle here. And the right triangle, if I say the hypotenuse squared is equal to the sides squared, a squared plus b squared. Well, in this case, what we had to do when we did the Pythagorean Theorem is we did have to take the square root of both sides. So when I take the square root of both sides, I get c is equal to the square root of a squared plus b squared. Well, we can say, and I'm going to go ahead and say that this side is a and this side is b for the purposes of the demonstration here. The way that we found this length of 12 is we took the difference of the x values. So I'm going to say c is equal to, and now instead of calling it c for the hypotenuse, I'm going to call it d for the distance formula, or for distance. And the way that we found that 12 is what we did is we took the difference of the two x numbers. So I'm going to say x2 minus x1 to show I'm taking the difference of it. Now the Pythagorean Theorem says whatever that value is squared. Now I'm going to do the difference of the y's. That is what we found for that 5 of the right triangle. So I'm going to take the difference of the two y values that we have, and square that, and there is our distance formula. It's essentially just another way of writing the Pythagorean theorem. So what we're going to be using the distance formula for is obviously to find the length of things. You'll be given the coordinates of 2 points, and to tell whether they're congruent, you do the distance formula. To tell whether maybe what half of one is, maybe you find the midpoint, and then you use the coordinates of the midpoint in the distance formula. So we're going to be using this formula for a variety of things throughout the year. And it'll be one of those things that's kind of expected that you just commit it to memory at some point. But essentially, that is where the distance formula came from. And we'll be practicing it soon. But in the meantime, if you have any questions about how we did anything in this lesson, be sure to let me know, and I'll be happy to help you with whatever questions that you have. Until then, guys, thanks for watching.